Okay, good afternoon. This is the 2 p.m. talk on the blue track. The log rings don't lie. It's about logs. I think that many of us who are familiar with logs, we use it to our benefit, but also how can this be used by the attacker's point of view. Let's welcome Bleon Proko.
Thank you all. Thanks for being here. I'm very happy to again be part of BSidesNYC. Yeah, for those of you that haven't realized, I will be speaking today. I guess my badge tells you. If that doesn't tell you, there's a couple of slides that will let you know. But yeah, my name is Bleon. I'm a security researcher, cloud security researcher at Exaforce, where my main job is to find new sort of ways on how to utilize cloud or how to utilize cloud resources as attack vectors, and then try to find new ways on how to detect them. Now, in this topic, we will talk about how logs can be used as an enumeration method. This is, I should preface by saying that this research is not complete. This is just one part of a large research that I'm currently doing on how to use logs as a way to commit different sort of attacks, like exfiltration, enumeration, command and control, exfiltration, infiltration. So this will be just one subset of that, and then you can also ask me questions about the rest of the research that I'm currently doing. And as I said, as part of a not finished research, there are a couple of stuff that I'm aware are not included in here that I will try to talk about, but of course, just bear with me on that part. Also, this is part of an ongoing research trend that I've done for the last couple years, where I take different cloud features and I try to weaponize them. So using what the target will have, so either defaults or what the target is currently using, and turning them into attackers' tools. So basically, a sort of living off land with cloud features. Now, cloud has each cloud provider, and another preface is that we will talking about the main cloud providers here, AWS, Azure, and GCP, but the concepts in here apply to basically all the other cloud providers. This is just a template, and each one of them has, if I'm not wrong, the last time that I saw, AWS alone had about 480 services, but correct me if I'm wrong on that one. So we're talking about 400 plus services on each cloud provider. Each one of them, or at least not most of them, each one of them will have their own logs. Each cloud provider will have a main logging service, and then they will have separate logs for each service that they will be using. So the job of Defender in cloud is to actually find out what is the best way to get into that. And as you can see, I'm also giving some examples there that are just examples like DNS logs, storage logs, which do exist on all of the cloud providers, but as I said, those are just a small subset, which boils down to each cloud provider. AWS, for example, as I said, too many logs. Two main services that you usually use for AWS are CloudTrail and CloudWatch. Now, CloudTrail is the AWS API logging service. So due to the fact that in cloud you manage everything through the identity, and you manage everything through the identity through the AWS API, you need a way to actually log those. That's what CloudTrail does. It will log all the events that are being done on the AWS API against specific privileges that you do have. CloudWatch, on the other hand, is a service that just collects logs from other places. It's not the only way to collect logs. You can just put them on an S3 bucket or any sort of storage. You can just forward them wherever you want. CloudWatch is helpful, due to the fact that you can also query them. You can easily access the logs, with the caveat that it does have a retention period, so you will, and also a higher cost, but you kind of get what you either get a cheaper, more permanent log source, or you get more expensive and less retention time, with the caveat of being able to query dashboard and everything. Now, this is where the easy logging basic stop because we go on with GCP. GCP does have the equivalent of CloudTrail, which is the audit logs. And the audit logs contain 4 types of logs. We have the admin activity, system, data access, and policy denied. The admin activity are basically each API accessed by a specific identity to do a specific task. System events are just stuff that Google is doing on your behalf. Data access are just, I probably should have also put that one here. There's also one type of log in AWS which is called the data event logs, which are events related to accessing specific data, like accessing files in a storage, downloading, uploading, deleting, everything. This is the equivalent for GCP and some more, because I also saw some, as we will see later, I saw some other stuff on the data event. And each GCP organization will have some restrictions by default implemented, and you can also implement your own, which they call organization policies. The last type of log will detect everybody that tried to run something and was blocked by them. Each of the audit logs will be applied on projects, which are the equivalent of accounts in AWS, so places where you can put your own resources, in folders, which are groups of projects. Billing accounts are basically for everybody that uses Azure subscription, but not necessarily subscriptions, are just a grouping of payment methods that you can add on Google, so that you can apply basically pay-as-you-go subscriptions on each of the projects or resources that you do. And organization, which is basically for the people that come from Azure or AWS, same as the AWS organizations or the Azure tenants, the whole grouping of basically everything else. Other types of logs in GCP, we have resource logs, and the resource logs depend on what type of resources you will have. You have security logs, you have service-specific logs, as I said, the resource logs. You have transparency logs, which are actions taken by, actions taken by Google on your own account. And again, as I said, these are the only ones that I've tested. There might be other ones, sorry. This is at least as far as I've gotten. Then we got Azure. Azure, for those of you that has had the unfortunate, of using, is split into 3 parts, 3 main licenses. You have the subscriptions, the cloud aspect, the infrastructure aspect of Azure. You have the Entra ID, the Azure AD for those of you that can still continue the tradition, and the M365. Those are the 3 main licenses. All of them do have logs of their own. You do have your normal activity logs in Azure. Then you have the resource logs, again, as we said, and then you have metrics, which are just if an instance has a high CPU, low CPU, if it's up, if it's down. You have M365 Purview Audit, which is basically the Purview is a service that you use to collect all of your logs, and then you have the audit logs. In there, you have the security system logs. M365 comes with a lot of products. Some of them are security related, like the DLP, the MD, EMD, the Defender for OneDrive, and so on. And then you have other service specific, which are not security related logs. And a bunch of Entra ID logs that, as you can see here, and all of them can be, again, configured based on what you want. For this case, we will use, for Entra ID, we'll be using the sign-in logs only, again, for a reason of time. But yes, you have a lot of them, a lot of logs that you can use. Now, bless you. Now, as far as enumerating logs enumerating resources and enumerating cloud using logs, this is not a new technique. This has been used. This is actually something that kind of as attackers we think about doing. We are limited into an infrastructure. We want to get more information. We don't have access to get more information. We use what we can get. Now, logs contain information. Okay? logs contain information about different stuff that specific identities are doing on a specific resource on a specific part of the cloud. Can us as attackers utilize that? Of course we can. What can we get from logs? We can get a list of identities. We can get a list of sources where they come from, which can help, especially when with cases where you have geolocation limitations. You can get failed attempts, which means what you are or allowed, and failed attempts of events, which means what the identity is allowed and is not allowed to do. You can get information about their endpoint through the user agent. You can get information about other resources on cloud through the input and output parameters on the cloud. So on the logs. So there are different stuff that you can do in them. And for this specific reason, for this specific case, we will be using 4 types of logs, which are the AWS CloudTrail logs, the Azure Cloud Audit Activity logs, the Entra ID audit logs, and the GCP audit logs. Now. One thing that I did mention a bit previously is that for each cloud provider, you will be having retention periods. Each cloud provider, in the absence of you having a SIEM of your own, will be allowing you a specific amount of time to have logs stored on their on the account, or basically their own version of that. And they do have specific retention time, which comes by default, which is usually 30 to 90 days, depending on the cloud provider, and then it can be, you can use another cloud-native solution to extend the retention period. Now, as far as CloudTrail logs go, what can you retrieve from a CloudTrail log? Each log, and not just the CloudTrail, usually will be outputted in a format that you would want. AWS by default does have JSONs, but you can output everyone in a format that you would want. And for each one of them, as I said, you can get different informations. Now, what can we get from the CloudTrail logs? We can get the activity being performed. We can get the credential that they are using. Now, based on the format of the credential, you can guess what type of identity this is. Is that a permanent identity, or an IAM user or role, or an IAM user, or is it an identity with temporary credentials, like an IAM role? You can get the identity's name. You can get each CloudTrail log will have a section itself where they contain all the resources that were affected and their resource types. And the way that AWS manages them is through a format of AWS, two double quotes, the service, and then the type of resource, which makes it easier for you to sort of create a graph, even collecting those. Then we have the second part. We can get information about the account that this operates into. You can get information about, again, the identity that is executing that. Is the identity, again, using temporary or permanent credentials? You can get information of the IP. You can get information of the request and the response parameters, which are the input and the output of each execution. Almost each execution, some of them do not give you outputs by default, and some of them, especially the ones that are being done in the backend by AWS, will usually show null. In one or both of them, we have seen a lot of cases of those, especially the one that comes to my mind is the quarantine policy, where the policy is applied, the execution is being done by AWS, and the request and response parameters will be null. But if some execution is being done by an identity, for the most part, you will at least have request parameters. Then we have GCP logs. For the GCP logs, you can get exactly the same type of information that you would get before. Just that right now you do see different types of identities that are executing the event. Due to the fact that in Google you can have permanent credential users, which are called service accounts, you might have that as the identity executing, or you might just have a user that just logs in to the and authenticates to the API and then just executes that. In our case, we have a user at domain.com, which if we continue down that down that line, we can get again a list of names that can be retrieved. Again, we can get the event being executed, we can get resource information, and we can get the response of the execution. Again, same sort of information as we retrieved earlier. And this continues again on the Azure. We again get the UPN, which is basically the user's email. The user's email in cases of a service principal. It will if I'm not wrong, it will be the client ID. Correct me if I'm wrong on that one. You can get a tenant they are operating on. You can get network information. You can get the events. You can get the status if it succeeded or not. Now we will see. The reason why I'm continuing to talk about the status is because we will see a technique on how to actually programmatically enumerate privileges using logs. Yes. Now, one other thing that we can do, as we said before, we manage cloud through the identities, and we manage cloud. No, we manage cloud through the API using identities, which means in order for us to be able to manage a specific part of the cloud, we need to have those permissions to be able to do that. Now, in all cloud providers, there are two main groups of permissions. You have the API permissions and you have resource-specific permissions. Both of the permissions can be added and they can be removed. What we can do is we can go and search for events which do have those addition, and by the way, I should have also added the removal in here, and we can again create a graph of our own of what a specific identity is allowed and not allowed to do, and what resources they are allowed to access and what resources they are not allowed to access. So in case we have an identity that we are not sure what privileges they might have, just looking through that will give us an idea. What I said before, due to the fact that we have statuses of responses for the specific task that we do, we can go and search through all the logs and then try to find out which ones of them are allowed or not. Sorry, hopefully you can hear me here. Now, whenever you are searching through logs, usually they will have a specific limit. It might be 1,000, it might be a bit more. You can retrieve it once. Okay. Okay, then sorry. Yeah, I thought you could hear me. Yeah. So I will try to move it like this. You will be able to retrieve those logs. Now, if you go and retrieve the logs, what you can do is you can list them, and by default, each log will be ordered reversely from the newest to the oldest, and then you can go through all the logs for each identity and then say, is this event being allowed, or is this event being denied? If that is denied and the event is newer and we are, the identity is not allowed, then we can just go for permission denied. If the event is allowed, then we can say that this event is allowed. So right now we can just go and query and go through a loop and query all the identities and all the permissions that they will have, and then see which identities does have each permissions. Now this comes with a big caveat, the fact that not necessarily somebody will execute something that they have access to, and we do have cases of permissions being temporarily given and then later removed. So I might be given access to a specific type of permission, I execute that is removed, I don't execute it again. The previous example will just show that as permission allowed, though that permission is not. So it does come with a big caveat, but for the most part, especially for permanent or for long-term permission giving, you will be able to actually find out what an identity will be allowed to do and what not. Secondly, we have the sign-in logs. Each sign-in log, each sign-in log will contain some information regarding the identity that will try to sign in. Now, different cloud providers have different methods and different services that do manage sign-in into cloud. And as an extension, they will also have different logging for that purpose. But for the most part, what you will be able to get from that is if the identity is using a specific mechanism like an SSO, if the identity is The name of the identity, again, the endpoint information due to the user agent. You will be able to find out if they are allowed or not, and from the error field, you will be able to find out if that identity just failed attempts because they just mistyped the password, or if they were locked, if the identity is not allowed to log in anymore, for example, due to the fact that they left the company. We will be able to find out all of that just by querying through logs. Now, going again through each cloud providers, AWS has 3 ways of managing, and just one event that we care about, for managing user sign-ins into the AWS console. The first one is through something called the login profile. IAM users right now in AWS are sort of in deprecation feature, but people use them a lot. IAM users are identities with permanent credentials. If you want that user to have access to the management console, to the GUI, the browser, to have browser access, you can give them what is called a login profile, which is a fancy name for saying you can just give them a password, and that's it. And then they can just go log in, and then you can also have you can give them some sort of MFA when they log in. Second one is through a technique called federated credentials. For the people that have used the NetSPI AWS controller, you kind of know the technique. But basically the idea is you get a set of credentials through a specific API, which is STS get federated token, if I'm not wrong, get federated key, get federation key, and then you pass them through the sign-in process in AWS, documented sign-in process in AWS, and they will give you back a URL, which after passing you will be able to get access. An identity going through this process does not have to have a login profile to get access to the AWS console. And the third one is through the identity center. Basically, whether you can connect the identity center through an IDP like Okta or just using that to log in. Using that, you can just log in through an email, a password, or some sort of other factor authentication. And each one of them will have different fields that you will be able to detect in the cloud that what type of identity this is. For a login profile, using an IAM user and authenticating with a login profile, 2 of the main things that you will be able to notice are, 1, the fact that the ARN does show user in here, and secondly, each authentication through the login profile will have a field on the additional data of login to. This is where you are allowed to log in. Basically, that's just saying that this is how the credential managed to access the management console, which is different from a federated set of credentials. Now, for the people that see that, if you have ever used Paku, you will see that imported dash is actually an event done by Paku. Paku does put imported dash on each session that they get, but that part there, imported attack user, can be anything you want. This is what AWS calls a session name. Basically, when you get a session of any sort, you assume a role, you get credentials, you get some sort of temporary credentials, you can put any name you want. That can literally be just attack user, and it's going to be fine. You can see again that the principal is the imported, but the ARN in here says federated user, which this user is not. This doesn't have any sort of on-prem to cloud connection. This infrastructure doesn't have any on-prem to cloud connection to go and authenticate stuff. It's just one API call that allows you to do that. And as we can see again here, you do not have the event, the field of logging to, because this identity did not technically go through a normal authentication. They were given an authorization URL to go and access the management console. They did not go. Their authentication process is just the permission to execute the call. That's literally what the authentication process is to them. And lastly, we have the identity center. Now, for the people that have used AWS and have configured the identity center, one thing that you will know is that this can be altered, of course, but by default, the identity, each identity or all of them together will be given a role, and that role will have specific permissions for you to access the management console. By default, they do have a format of AWS reserved SSO underscore administrator access underscore some alphanumeric characters. As I said, that can be anything, but one thing that you do see differently from just a role trying to access something is the fact that in the end the name will be the name part of the email of the identity that is logged in, which means this role here can be given to anybody on the company. Bleon is the one that accesses this because Bleon, through the identity center, through an authentication method, was authorized temporary credentials to access the management console, and they were given this session with this role here. And again, as I said before, we do not have a login to field because again we did not go through the normal authentication process that the login profile will go to. We went through another mechanism which technically is a service in AWS, but it's not the service that allows you to log in through the account, user, and password. And the Entra ID. Entra ID, one field that is important or one field that is different from Entra ID is the additional details. Now, additional details contains information regarding the output of the authentication from a specific identity, and you have, these are the ones that I've managed to find so far, and I'm pretty sure that there are more. I just, these are the ones that I've managed to collect through all of my tests that I've done. You will have a complete login, MFA accepted, MFA not accepted, the user, you will have a message for the user checked, remind me again, which means you can understand the flow of somebody getting, logging into an infrastructure. And for the GCP, now, when you log in through a user in GCP, your events will actually show as Google Workspace events, but strangely they will be part of, and I should have added that, sorry, they will be part of the data events, which kind of weirded me out because the data events technically were supposed to be data related, data access related events. They do store those in there. One good thing that they do have differently from others, and the reason why I'm not showing all the fields in this case is because I'm just showing you differences between one and another. You can get the same type of other information from all three logs. What I want to show here is what other information you can retrieve from provider-specific logs. In this case, what they do offer is just login success or failure, so you can just filter out whatever identity you want and just see if they are allowed or not allowed, and for what reason they weren't allowed to log into the organization. And yes, in the end, as I said, as a technique, now I'm pretty sure some of you might be thinking, okay, why the hell did he just come up with all of this? As I said, as a technique, this is known. And to my knowledge, there is even a Mitre attack technique just for log-based enumeration. What I'm trying to show you here is how you can achieve that technique on specific providers in cloud, and how you are able to do all of that, and what information can you retrieve from each one of them based on authentication mechanisms or access mechanisms that you will be having on those cloud providers. And if you are thinking about how do you detect or prevent this, detection in this sort of technique is not that easy due to the fact that a lot, and I mean a lot of identities, especially programmatically, will be allowed to access logs. And there are roles, and this is one part of the research that I'm working on, there are roles that specifically allow you that are not monitoring related, that do allow you to list specific kind of logs, due to read or write specific kind of logs. So you will be able to achieve a specific task with just a minimal access on the cloud providers. And very sorry if I brushed through that. You will be able to achieve everything through just this much events. For the people that do penetration testing in cloud, you will know that cloud is annoying, except for Azure, but that's another thing. It's annoying when it comes to enumeration due to the fact that cloud handles permissions in whitelisting matter. You are not allowed anything, then you are allowed to do stuff, which makes it really hard, because either you are just going to just fuzz permissions, and good luck doing that when, I'm very sorry, the permission is the right permission, which means you will be tampering something, or God forbid, deleting something. So you will need to find out another way when you are not, when you do not have access to know what kind of permissions you have. And this is part of the research that I'm doing. And as far as preventing goes, the best way to prevent, I'm very sorry to say, is a least privilege. So just be aware of who you allow to read logs. It's not easy to do, and I'm one of the people that just say it's not easy to do that. But it's literally the only way to do that, because otherwise you will be allowing somebody else to read the logs. You cannot just blind the defender by not logging. You should log, because that's information, important information for you. But what you can do is quite literally just go and be aware of who can read those logs, so that the people that need them can keep them, and the people that don't need them cannot abuse those. And with that, thank you very much. I guess it was a shorter presentation than I expected. Thank you. I don't know, do you have any questions? Yeah. Yeah, so yeah, so for those that didn't hear that, the question was, if I'm not wrong, how common is for threat actors to actually utilize those in their day-to-day process? It's basically their day-to-day process. So a threat actors or threat hunters? Threat actors, I don't know of any threat actor, at least at the top of my head, that does utilize that. As I said, it's not easy to detect due to the fact that if you are allowed to specifically do something and you have done that before, it's kind of hard to find out if it was you or somebody else that did that. To my knowledge, there isn't any threat actor that did that, but I would presume that some sort of log enumeration, some sort of them, is being done by threat actors, even when it comes to just debugging the output of a specific task that they did. So I believe they might be doing, I just don't know at the top of my head. Okay then, thank you very much. Thank you.